Hello guys, my name is Simon Tang and we'll be doing the sampling distribution model and confidence interval analysis with the proportion of people who need eyeglasses. Approximately 64% of adults wear corrective lenses or eyeglasses. We chose to research the proportion of people who need eyeglasses according to the American Optometric Association of 2020. This statistic was also supported by the Vision Council 2019 Vision Watch Consumer Survey. All right. And this is the sampling distribution model of what I got from my surveys. The n equals 30, or people participants, or data points. The standard error is equal to the square root of p of 1 times p times 1 minus p over n is equal to the square root of 0.64 times 0.36 over 30, which approximately gives you 0.087 for the spread or standard error. So the shape of this is approximately normal by the central limit theorem, and the center, as you can see, is 0.64. P equals 0.64. And as you can see in this visual, it shows the bell curve centered at 0.64 with the standard areas of 1, minus 1, 2, minus 2, 3, and negative 3 and positive 3. And that's essentially it. Data collection and observed proportion. I surveyed 30 people and collected a sample of 30 individuals, and what I got was that 18 out of 30 people reported that they need or they are needing eyeglasses. So the observed proportion is that 18 out of 30, which is 0.6 And to get the z-score calculation, we first get the observed proportion minus p over our standard error of 0.0877. I forgot a 7 on the slide, but that approximately gives you, for z-score, you need to do 0.060, which is the observed one, minus 0.64, which is p, over 0.0877, which approximately gives you negative 0.456 for the z-score. And this indicates, the z-score of negative 0.456 indicates that the observed population, or the observed proportion, is well within 2 standard deviations of the expected mean. %95 confidence in interval construction, which is part of the rubric. So the conditions do check. It's a random sample, and 30 times 0.6 equals 18, which is what we got from earlier. And the observed standard error that we have from this, you can get that by doing the approximation, by doing the square root of 0.60, which was our p, times 0.40 over 30, which approximately gives you 0.0894, which is the observed standard error on here. And the margin of error, or ME, for the 95% confidence interval is 1.96 times the observed standard error, which gives you approximately 0.175. And using this value and the other proportion of the people who need eyeglasses, we are 95% confident that the true population, or the true proportion of adults who need eyeglasses, is between 42.5% and 77.5%. The research population is 64%, falls within this interval, supporting my research. The summary and conclusions are just what we got from our whole presentation. It's normal with the mean of 0.64 and standard error of approximately 0.0877 for the sampling distribution model, and the observed data is a sample proportion of 0.60, which is 18 over 30. The z-score is approximately negative 0.456, which is within the 2 standard deviations that we need. 95% confidence interval is from 42.5% or 42.5% and 77.5%. So the conclusion is that the data is consistent with the research population, and our sample's confidence interval includes 64%, showing that our sample does not significantly differ from the research value that we got from the very start. That's essentially all of it, and let's move on to the references. References from American Optometric Association from 2020, retrieved from Vision Council, and also the last part, Moore, Diaz, McCabe, Introduction to Practice of Statistics. That's it. Thank you.